welcome to the Uptime Alliance YouTube channel. My name is Victor Mzembe, a biomedical engineer for the Uptime Alliance. In this video, we tackle the second part of a video in which we tear down the CodeMaster manual defibrillator. For this part, we will demonstrate a step-by-step procedure of component removal to provide support with component replacement, the working principle of the device, as well as the electrical system. So stay with us. This being a critical device, it is recommended to replace an entire board that is suspected of a malfunction rather than replacing a component on that board. In the first video, we successfully disassembled and removed other components such as the CRT assembly, the power supply, and the main control board. So let's take it up from there. Firstly, I'll show you how you can remove the recorder. So the recorder can be removed without opening the device. The recorder is secured by 4 Torx screws. To access these screws, you first need to open the recorder door, this one here, and also removing this plastic label. Right here, we have 2 of the 4 Torx screws. To access the other ones, you need to open the recorder door. Next, you can lift up the recorder. After doing that, you need to disconnect the cable that runs between the recorder and the main control board. This right here is the recorder packet. To remove this recorder packet, you would first need to open the device and then unlock the hinges that secure the packet to the chassis. Now, let us look at how you can remove the key panel assembly. The key panel assembly can only be removed after removing the recorder and recorder package. It is secured by these 3 clips in the top cover of the chassis that have to be unhooked. After removing the grips, you can slide out the key panel assembly. Next, there are 2 Torx screws that secure the key panel circuit board, the key pads, the plastic rings, the bezel securing the circuit board, as well as the key labels. To remove these screws, I will use a Torx T10 key and a nut driver. The key panel circuit board supports push-button switches and LED indicators. It is interfaced with the energy select control by a flex cable. To replace this board, you will need to disconnect this connector using a flathead screwdriver. As you can see, this is the bezel. Now, I will reassemble the key panel assembly. As mentioned in part 1 of this teardown video, right here is the ECG front-end control board. Remember that before removing any of these components that you see here, the high voltage capacitor should be discharged. This board can be removed by first disconnecting the wires connected on it and also the cable assembly that runs between the ECG input connector and the board. To remove these wires, you can use a flathead screwdriver to lift up the pins. Next, the QRS beeper volume control can be removed using a nut driver and a T10 Torx key. The ECG input connector can be removed by squeezing the plastic ears on the connector, after which the connector and the cable pulls out to the front of the device. This one is the plastic ear with the other one on the other side. The ECG output connector right here can be removed using a pair of pliers or a spanner. The next step involves removing the 5 screws that secure the board using a nut driver and a T10 Torx key. So right here is the ECG front-end control board. And this one is the connector for the cables that run between this control board and the main control board. And over here is the ECG input connector. Having looked at how you can remove the ECG front-end control board, now let us look at how you can remove the high voltage charger and relay assembly. As mentioned in our previous video, this assembly consists of the high voltage capacitor, the patient inductor, the patient relay, and the high voltage charger board. It is always important to ensure that the high voltage capacitor is discharged before touching any of these high voltage components. To remove this assembly, start by disconnecting the battery connector board by removing this black rubber and releasing the locking latch, securing the board in place. After disconnecting the battery connector, I will use a T10 Torx key and a nut driver to remove the screws fastening the assembly to the chassis. 2 of these screws are located on the high voltage control board, and the other 2 are located on the high voltage capacitor case. After doing this, remove the standoffs that secure the high voltage control board to the assembly. This standoff right here should also be removed to easily remove the high voltage capacitor. To remove these standoffs, I will use a 5x16 inch nut driver bit and a nut driver. So this right here is the high voltage charger and relay assembly. To remove the patient relay, we have to disconnect the wires running between the patient relay to the high voltage capacitor, the patient inductor, and the control board. There is also one wire that runs between the patient relay and the patient inductor. So you need to disconnect the two wires. After doing that, I will remove the single screw that supports the patient relay to the high voltage control board. So this is the patient relay. Next, let's look at how to remove the high voltage capacitor. Note that this capacitor can also be removed without removing the whole assembly. To do that, you would need to remove the three standoffs that we earlier removed on the capacitor side, and also the two screws that secure the capacitor cover. There is one plastic brush on the left of the capacitor that can be unhooked using a flathead screwdriver. The two latches on the other side are unhooked after opening the plastic cover to the light. This is the high voltage capacitor. This capacitor has a capacitance rating of 34.8 microfarads with a tolerance of plus or minus 7.5%. It has a voltage rating of 5.3 kilovolts. As earlier mentioned, make sure that this capacitor is discharged before you touch it. And you can discharge this capacitor by shorting these two terminals using an insulated screwdriver. Remaining on the assembly is the patient inductor. The inductor can be removed by removing the retaining clip that secures the inductor using a flathead screwdriver. Right here is the patient inductor. During replacement, the inductor wires should face towards the center of the chassis, followed by installation of the plastic retaining clip. The shortest lead wire from the inductor should be connected to the shortest lead wire on the patient relay, with this longer wire from the inductor connected on the high voltage control board. Now, let us look at the CRT assembly. Located on the CRT assembly is the CRT deflection control board. This board drives the electron beam to generate and display real-time ECG waveforms. And over here is the CRT. The CRT can be removed by disconnecting the high voltage connection right here from the side of the CRT. Next, I'll disconnect the CRT deflection connector right here and also the connector board. After doing that, I will remove these 4 screws that secure the CRT to the assembly. To do that, I will use a T15 Torx key and a nut driver. Next, I will remove this screw that is tied to the ground wire using a T10 Torx key and a nut driver. After doing that, I will slide out the CRT. So this is the CRT. You can also slide out the CRT deflection board. Right here is the CRT deflection board. This one right here is the CRT deflection connector. This one is the high voltage connection. And this one is the cable connector for the cable that runs between the CRT deflection board and the main control board. Now I will assemble the CRT assembly. Next, I will reassemble the high voltage charger and relay assembly. Next, I'll put back the ECG front-end control board. After doing that, I'll put back the ECG input connector, the ECG output connector, as well as the beeper volume control. At this point, let us look at the power distribution throughout the device before we proceed with the reassembly. When operating on AC, the power supply converts AC into 5 and 12 volts DC that are needed to power the defibrillator logic and display circuits. The power supply also provides approximately 13.5 volts DC needed to charge the battery and power the recorder. The control board right here distributes power and control signals to the other components. The power supply is also interfaced with the high voltage control board through this cable. From the high voltage control board, power is supplied to the high voltage capacitor and the patient inductor. The switching of high voltage to these components is controlled by this patient relay. Together with the patient inductor, the patient relay controls the charging and discharging of the high voltage capacitor. Electrical energy is delivered from the high voltage control board to the defibrillator connector through the ECG front end board. And these two right here are the cables that deliver electrical energy to the connector. When the device is operating on battery, DC voltage is supplied to the input of the DC to DC converter on the power supply control board, as well as the high voltage charger board. Having looked at the power distribution, let us continue with the assembly. Next, I'll put back the CRT assembly. Now, I'll put back the power supply assembly. Next, I'll put back the key panel assembly and the recorder. Now let us look at an overview of how this device works. As mentioned earlier, this device operates on AC or internal battery power. It can operate as either a defibrillator or a monitor, and it has a setup mode. In the defibrillator mode, the energy select control is turned to the desired energy level, and this powers on the defibrillator. When the charge button is pressed either on the Q panel or the defibrillator paddles, the high voltage capacitor gets charged and ready to deliver defibrillation energy. The high voltage capacitor is fully charged if the charge done indicator illuminates. The monitor displays the available energy in joules. If the defibrillation energy is decreased, the safety relay closes to trigger an automatic high voltage capacitor discharge. During a shock, defibrillation energy is delivered to the paddles once the shock buttons are pressed. The high voltage capacitor is discharged through the patient inductor into the patient load. The patient relay isolates the high voltage board from the capacitor. In defibrillation mode, this energy is instantly delivered to the patient. If the device is in synchronization mode, the defibrillation energy is delivered only when the device detects the next hour wave in the patient's heart rhythm. The defibrillator can be disarmed by turning the energy select control to the monitor on position. This device can also be used as a monitor for cardiac monitoring. For this mode, the energy select control should be turned to the monitor on position. ECG data is acquired using ECG leads. The data is then digitized by the ECG front-end board and then fed to the main control board, where it is processed by the digital signal processor. Once processed, the data is sent to the monitor processor for monitoring. Note that the fully charged battery can continuously sustain this mode for about 2.5 hours. That is all for this video. We hope that you learned something new from it. Don't forget to like, share, and subscribe to our YouTube channel. Until next time, bye.